In today's video, we're going to be going over atomic structure, and we're specifically going to look at the composition and also the structure of all atoms. So here in this middle, we can see that this is a picture of an atom, and this is also the structure and how the composition of an atom looks like. So in the middle, for example, we have a nucleus, and inside of this nucleus there's protons and neutrons, and then outside these are all the electrons. So we're going to look more in depth inside of this atomic structure in this video. So starting off, we're going to talk more about the composition and structure. So first of all matter is actually made out of atoms. And atoms are made up of even smaller particles, and these are known as subatomic particles. So as we can see here on the right, this is a picture of an atom, and all matter inside of the universe is actually made out of these atoms. And then atoms are made out of even smaller particles, and these are the different smaller particles which we call subatomic particles. So for example, there is the nucleus, and inside of this nucleus there's the proton, neutron, and then orbiting this nucleus there is the electron. So just to summarize, all matter is made out of atoms, and then atoms are made out of smaller ones, which is called subatomic particles. So now for the properties of subatomic particles. So we can see here that there is a table. So inside of this table, we're going to talk specifically just about the protons, neutrons, and electrons. So for the symbol of the protons, it's P+, and the reason why there's a plus is because the charge is +1. And the location of this proton is inside of the nucleus, and the approximate mass is 1 AMU. And we're going to explain what 1 AMU is in just a little bit. But for the second one, which is neutrons, the symbol is N0, and the reason why it's 0 is because it has no charge. So it has a charge of 0. And the location of it is inside the nucleus, and the approximate mass is 1 AMU again. And finally, for the electrons, the symbol is E-, and that means it has a charge of -1, and the location is outside of the nucleus, and we know that it orbits the nucleus, and the approximate mass of it is 0. So what is actually 1 AMU? So one atomic mass unit is defined as 1/12 of the mass of a carbon-12 atom, which is approximately equal to 1.66 times 10 to the power of -24 grams. So basically we're just saying that one atomic mass unit, we're just comparing that with a carbon-12 atom, and that the weight of a carbon-12 atom is approximately 1.66 times 10 to the power of -24 grams. So in summary, this is just the properties, and we can see the charges of all three of these different subatomic particles. More on the properties of subatomic particles. A neutral atom will have equal number of protons and also electrons. And an example of this is oxygen. So oxygen has 8 protons inside of the nucleus, and so the atom will be neutral because it has 8 electrons orbiting the nucleus. So as we can see here in this picture, a neutral atom will always have an equal number of protons and electrons. So for instance, as we said, we're going to take the example of oxygen. So here we can see that oxygen has 8 electrons. And since it has 8 electrons outside and also 8 protons in the inside, then that means those balance out and we get a charge of 0. So all neutral atoms will have equal number of protons and electrons. So now let's look at what an ion is. So an atom that has either lost or gained an electron is called an ion. And an example of this is oxygen can gain 2 electrons to form an oxide ion, or lithium can lose an electron to become a lithium ion. So in this case, what we're seeing here is that an ion is basically when an atom has lost or gained an electron. And an ion can either be a positive or negatively charged. So if we look at the example of oxygen, so all the atoms always want to have a stable octet. That means they want their outer shell to be full. So for instance, inside of oxygen, this one needs to get 2 more because it wants to have a full valence electron of 8. And since it has only 6 outside, it's looking for 2 more. So once it gains 2 electrons, then it's going to become an ion, and it's going to become a negative ion because it has 2 more electrons than the amount of protons. So this oxygen atom will become negative, and it's a negative ion. And if we look at lithium on the other hand, so instead of trying to gain 7, lithium would rather just lose 1 electron. So once lithium loses an electron, it will also become an ion, and this one will be a positive ion instead of a negative one. So this is what an ion is. And now for isotopes. So atoms that have the same number of protons but different number of neutrons is known as an isotope. And an example of this is that there are 3 stable isotopes of oxygen, so oxygen 16, oxygen 17, and oxygen 18. So basically, an isotope is just the same atom except that has a few more neutrons or a few less neutrons, and depending on that number, then that's what you name it. So instance, if we can look at this oxygen one here, this oxygen 16 one has 8 neutrons, but oxygen isotope 18 has 10 neutrons. So that's why these are two different. So that's what an isotope is just a different number of neutrons. And now, just to summarize, we're going to go over a few practice problems. So just need to connect the term with the definition. And also feel free to pause the video and try these questions out for yourself as well. So for question A, the charged neutral subatomic particle. And the answer for the neutral subatomic particle is the neutron. So the positively charged subatomic particle, this one is the proton. The total number of protons in the atom is known as the atomic number. The total number of protons and neutrons in the atom is known as the mass number. And finally, for the last one, we have subatomic particle that weighs significantly less than the others, and this is known as the electron. So that summarizes all the practice questions for this video, and that also summarizes everything for the composition of atoms. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.